Now we're going to talk about end behavior. So this is something you should have seen before, this little diagram where you talk about if it's an even degree, something like x squared or x to the fourth, as you go out in both directions, it goes up, up. So in other words, as x goes out to positive infinity, y goes out to positive infinity. Also, as x goes out to negative infinity, y goes up to negative infinity. And then if it is positive with an odd degree, as x goes out to positive infinity, y goes out to positive infinity. And if as x goes out to negative infinity, y goes down to negative infinity. So classic example of positive odd degree would be x cubed, and positive odd degree would be positive even degree would be x squared, positive odd degree would be x cubed. So let's see, negative leading coefficients. So as x goes down to negative infinity, looks like y goes to negative infinity, and as x goes to positive infinity, y goes to negative infinity. So this would be even, but a negative leading coefficient, so something like negative x squared would be down, down. And then a negative leading coefficient, but the coefficient is negative. Negative x cubed, maybe for example, is going to have up, down as its end behavior. So in general, we usually think of the even degree with a positive leading coefficient. Something like x squared is up, up. Even degree but a negative leading coefficient like negative x squared is down, down. Odd degree but a positive leading coefficient like x cubed is down, up. And then negative x cubed would be up, down. For its end behavior. So let's look at some examples. So if we interpret turning points, so a turning point is where a function goes from decreasing to increasing. So a turning point here is going from increasing to decreasing. So a turning point is just a minimum or a maximum. So here's some turning points, and here's another turning point. Okay. So it turns out that in general, a polynomial of nth degree will have at most n minus 1 turning points. So since this degree is cubic, the maximum number of turning points, n minus 1 is going to be 3 minus 1, or 2 max turning points. Here, if I was to multiply this thing out, well, this is going to give me x squared times some stuff. And this one is going to be x squared with some stuff in it, 2x squared. So it looks like my leading term, with this negative out here, is going to be negative, what, 2x to the fourth? So its degree is 4, so n minus 1 would be 4 minus 1, or 3 max turning points. Okay. Example 8, sketch a graph of this polynomial. So if I had to sketch a graph of this polynomial, what I would do is, first I'm going to find the x-intercepts, which is where y equals 0. Then I'm going to find the y-intercepts, which is where x equals 0. And then I'm going to look at the end behavior. So notice that this is just the same as the zeros. So the x-intercepts is the same as the zeros, right? So when I think about those zeros, I'm also going to think about that local behavior. So the local behavior near zeros is just the multiplicity, right? Okay, so if I were to multiply this thing out, I would get x squared plus, well, let's not do that. Okay. So first, let's do the x-intercepts. So the x-intercepts are where y equals 0. So I'm going to take my function and set it equal to 0, and what I get is that either x is equal to -2, I'm sorry, either -2 is equal to 0, which never happens, or x plus 3 is equal to 0, which would give you -3, and this is x minus 5 is equal to 0, which would give you a +5, or my only two x-intercepts. So far I have x-intercepts at -3 and 5. But then the y-intercept is where x is equal to 0, so I plug in 0. I end up getting -2 times 3 squared times a -5 is what? 10 times 9, which is 90. So up here at 90, I have an output, right? That's my y-intercept. But then I notice that this 0, so for x plus 3, its associated factor, I'm sorry, for x equals -3, its associated factor is x plus 3. And it has a multiplicity of 2, so that means since its multiplicity is 2, that means it touches there. And here, since this 0 has a multiplicity of 1, that means it crosses there, right? So again, since the 0 is x equals 5, the associated factor is x minus 5. All right. So then we look at our end behavior. If you were to multiply this thing out, f of x is going to equal, what is it going to be? Well, this is going to give you an x squared plus some other stuff. There's a -2 out front, and this one is x minus 5. So when you multiply that stuff out, I think it's pretty clear that the leading term is going to be -2x cubed, and then you're going to have a bunch of stuff. If you don't believe that, go ahead and multiply it out completely. So this means we would have an odd degree, but a negative leading coefficient. So negative and odd means we have up, down for our end behavior. So it means we have up and down at the ends. So as it's coming in towards -3, we said it touches, so it does this. But then we know at some point it has to go through 90, but then at some point it has to go back this way, and it crosses at 5. So it looks something like this. Okay? All right. That's example 8. Writing a function from this graph. So I guess when I look at this, the first thing I notice is that I have zeros here, here, and here. So I know that my zeros are x is equal to -3, x is equal to 2, and x is equal to 5. So if those are my zeros, then the associated factors are going to be x plus 3, x minus 2, and x minus 5. If you add in the multiplicity, since this crosses here, I think that's going to be to the first power. Since this touches, if I'm going to go least degree, I would have that as a squared, so it's going to be x minus 2 squared. So on a high stakes test, it would say, it says write a formula for this polynomial using, we probably want to say using the least degree possible. So here, notice it crosses, so this is going to have some sort of an odd degree. I'd say 1, right? So if I go x plus 3, x minus 2 squared, x minus 5. That would be one version of this polynomial, but notice I want it to go through this point negative 2. So there's really some coefficient a out in front that I don't know. And it turns out that when you plug in here, when you plug in 0 in for x, you better get out negative 2. So when you plug in 0 in for x, you better get out negative 2. So this is going to be 3 times 4 times negative 5. So it's going to be negative 60. So this is going to be, what, negative 60a is equal to negative 2. So now I need to find a is really what I'm doing here. And so this is going to give you 1/30th. So P of x is equal to 1/30th x plus 3, x minus 2 squared, and x minus 5 would be my final answer.